Just to reiterate then, there are several columns that are necessary for the analysis that we're going to do, and we've opened them up in a text editor so that we can identify which of the columns will be used when we import the data into MagPick. One other point here is that the positions are all in decimal degrees, and we'll need to know that when we import the data. We've got an idea of which columns we'll be using, and I'm going to open up MagPick. Now MagPick is a free program which can be downloaded from Geometrics Magnetometers Download. It is a processing program, and I'm going to go through the steps we take to import the data, to review the data, and then to generate an analytic signal map. Okay, the first order of business with MagPick is to import the file. So we do that, we go to File, Profiles, Simple Load. So we are going to make a simple load of the interpolator data that reflects these two magnetometers. You'll see that there is a checkbox here by Save as Profile List. This enables us to save the imported data in a list file so that next time we can skip this import load. So the first thing we do is hit Add, and we go to the interpolator file. This is MSF-DGOS survey interpolator.int. By the way, this data is available from us. It was collected in Pearl Harbor, and if you'd like to work with this data, you can send us an email at sales.geometrics.com, and we can make it available off our FTP site. So I'm going to open this data file, and there are several dialog boxes that open here, and so we're going to go over them one by one. The first one is how we split the data up. And if you remember in the Notepad editor, we saw that one of the columns was the line number. So we're going to split the data line by line based on the line number, and so that's what's in number 24 here. It says line. So we're going to accept the line as the process of splitting the data. Okay, first of all, for the first mag, we're going to input number 18, which is lon mag 1. That'll be X. Y is lat mag 1. And the data will be coming in on mag 1. So I go back down to mag 1. The depth will be depth 1. Go down to depth 1. The altitude will be altitude 1. So there's only one altimeter on the array, and its data is in altitude 1. We'll use time in case we want to do diurnal correction from a base station on land. So that gives us the time and the date, and it's already selected these columns based on the header information. We can leave the default active color red, inactive color blue, and down here is a very important selection. Apply UTM input on import, and if the positions are in lat long, we can supply a formatting procedure, either auto short UTM or manual UTM. If the positions are in latitude and longitude, they need to be converted to meters. We can either use manual UTM, which means we would supply the false eastings and northings in order to remove the large number of digits in the front of these files, or we can go with auto short. I'm going to select auto short, and it brings up a UTM transformation setup box, which is filled in automatically, and it's selected a false northing of minus 2,360,000 meters and a false easting of 600,000 meters. So in other words, it's going to remove these from the UTM coordinates being the positions from the central meridian of that sample, and also going to remove the distance in meters from the equator. Okay, in order to add the second channel, we use we have this selected and we add channel. Now, add channel, now we're adding the second magnetometer into the script that will load the data. And so the line number is the same, the longitude is long mag 2, the latitude or Y is lat mag 2, the data will be mag 2. So we go down to mag 2 and select that. The depth will be depth 2, which is already selected. Remember that the altitude, there's a single altimeter on the array, so we select altitude 1. The time and date is the same time and date. We'll use the same selections. And we'll also use the same auto short UTM. So in other words, this will be selecting the same false eastings and false northings in order to make the UTM coordinates smaller numbers and allow for higher precision gridding. Okay, we select OK, and now we'll note that in the script it has both mag 1 and mag 2 listed in the script file. We're going to save this as a profile list, and if I click OK, it'll ask us for that list file, and I'll call it demo list and .lst, or you can allow it to give it its own. Okay, now it's splitting the lines, and we loaded 56 profiles. So there were 56 profiles determined by the line number in the interpolator file. And so we select OK, and now the first graphic that we're going to load is, click on New and click on Grid View. And as we click on Grid, we see the actual survey lines as they were run approximately north-south in this example. The first thing we're going to do is to make it bigger so that we can see it easier. We go up to Options, Size, and click the X and Y up to about 3 or 4. I'll select 4. Zoom we can select up to 3. We can leave the left-right margins as they are for default at 50 pixels and select OK. And then it's asking whether we should redraw the map with a new resolution, and we're going to do that. And now I'll expand the map so we can see our actual grid file showing the survey profile lines. If we zoom in on this, we can actually see that we can do that through Edit, Zoom, and select this portion here. We can actually see that each of the lines has 2 magnetometers associated with it, and each line shows the 2 magnetometers side by side and the direction of travel.